Welcome to my YouTube channel, A Brainery of Civil. Today I am going to solve the third assignment of fluid mechanics. First question. In a two-dimensional duct flow, air flows in the bottom half of the duct with uniform velocity and there is no flow in the upper half. The value of kinetic energy correction factor alpha for this flow is, so if it is a pipe, the flow will be only on bottom half. So this is a velocity profile. So we need to calculate alpha value. So first of all, A into V average according to continuity equation, A by 2 into U. So we will get V average is equal to U by 2. Clear? So we have certain formula for alpha is equal to integral V cube into dA divided by V average cube into A. So that will be V is equal to U. So that is U cube into A by 2 divided by U by 2 whole cube into A. So you will get it is 8 by 2. So that is alpha is equal to 4 for this question. So question number 1 answer is C. Next question. A water jet with velocity 20 meter per second is directed upwards at an angle 45 degrees to the horizontal. If air resistance is neglected, it will reach maximum elevation at a horizontal distance x from the nozzle, the value of x. For example, it is something like a projectile formula. So this is making an angle 45 degrees with horizontal. So somewhere here maximum height. So maximum height is reached. So at which horizontal distance? We have a formula for this. R is range is equal to U square sine 2 theta by G. So now x is equal to R by 2. So that will be U square sine 2 theta by 2G. So U square is 20 square sine 2 into 45 divided by 2 into 9.81. So you will get x is equal to 20.37 meters. Clear? So it is something like the path of projectile is a parabola. So when we throw a ball, it will follow the parabolic shape. So when we throw the liquid at certain angle 45 degrees. So what is maximum height reached at what horizontal distance? So for this question 20.38. So answer A is okay. So and in a turbine having flow that is discharge 1.2 meter cube per second and net head H is equal to 120 meters, efficiency of turbine eta is equal to 90% and shaft power SP is equal to. So first of all we need to calculate hydraulic power. Hydraulic power is equal to gamma QH. So gamma is 1000 into 9.81. Q is equal to 1.2, H is 120. You will get 1412640. That is 1412.640 kilowatt. So now shaft power is equal to hydraulic power divided by efficiency. So that is 1412.640 divided by 0.9. You will get it is 1569.6 kilowatt. Answer is C for question number 3. So now continuity equation deals with the law of conservation of, obviously it is law of conservation of mass. It is a direct question. So question number 4 it is A. And now next question. Water flow studied down a vertical pipe. So this is a vertical pipe. So the water is flowing. This is a section 1 and this is section 2. So the water is flowing in this direction. Clear? So constant section neglecting friction according to Bernoulli's equation is. So what is the Bernoulli's equation? Summation of pressure energy plus velocity energy. This is also called as kinetic energy plus datum head is equal to constant. So this is Bernoulli's equation. Now I will apply this at the section 1, 1 and 2. Z1 plus P1 by rho G plus V1 square by 2G is equal to Z2 plus P2 by rho G plus V2 square by 2G. As we move from section 1 to 2, that is from in the direction of flow, height decreases. In this direction, height decreases. As height decreases, pressure also decreases. Pressure decreases with height. With height means we need to travel along the direction of flow. Okay, so pressure decreases with height. Option C is the answer. Clear? Next question. The necessary condition for the flow to be unsteady. Steady means all the parameters of the flow with respect to time are constant. Then we call the flow is a steady flow. If all the parameters, for example, acceleration, velocity and density, if all these parameters are not constant with respect to time, we call it is unsteady flow. That is, velocity changes at a point with respect to time. Okay, so answer is B for question number 6. And which of the following is an intensive property? So first of all, we need to define what is intensive property and what is extensive property. Intensive property do not depends upon the quantity of matter. So I can write here. Intensive properties depends on quantity. So here mass is a quantity, volume is a quantity, and energy is a quantity. Remaining only density, it is not a quantity. Okay. So extensive properties not depend upon the quantity. Intensive properties depends on quantity. So out of all this, density is extensive property. So density is intensive property. So I am writing definition. Intensive property not depend on quantity. Okay. So here mass is a quantity, volume is a quantity, energy is a quantity. So that is A, C, D are extensive properties. Extensive properties, they depend upon quantity. Clear? Now, next question. Identify the statements below and choose the correct answer. Statement A, control volume focus on set of fluid particles. Statement B, a control volume can be fixed, movable or deformable. So first of all, we need to define control volume. Control volume in space of special interest on a particular fluid particle. Special interest on a particular fluid particle. Okay, so this is particular set of particles will be characterized by control volume. Option A is correct. And obviously, a control volume can be, it may be a fixed or it may be a movable or it may be time being changes. So, both A and B statements are correct. Option B for question number 8. Now, does the velocity field he has given some vector represents a possible incompressible fluid flow. Now, so he has given V is equal to some vector, 3D continuity equation for incompressible flow. So dou U by dou X plus dou V by dou Y plus dou W by dou Z is equal to 0. This is coefficient of I is U, coefficient of V is, coefficient of J is V, coefficient of K is W. Now I am differentiating dou U by dou X is equal to 5 3 is 15x square and dou V by dou Y is equal to minus 15x square and dou W by dou Z is equal to 0. Okay. So now the summation is 15x square minus 15x square is equal to 0. So that is del dot V bar is equal to 0. It satisfied continuity equation. So it is incompressible flow. So that is yes, answer A for question number 9. Now, Reynolds transport theorem, that is RTT, applies steady flow. Yes, it is applicable for steady flow. It is applicable for unsteady flow, and it helps to conserved properties, applied in conserved properties. So both A and B are correct. So these are all theory questions. And next question. So very important. I am just zooming here and again. A syringe as shown in figure is used to inculcate a cow. The plunger has face area 500 mm square. The liquid in the syringe is to be injected steadily at a rate of 300 centimeter cube per minute. The leakage rate past the plunger is 0.10 times the volume flow rate out of the needle. Find the at what speed in mm per minute should the plunger be advanced. Plunger be advanced. Okay, so we need to solve this. So let Vp is speed of plunger, and by conservation of mass, that is Q is equal to area of plunger into velocity of plunger. Here Q is equal to Q leak. There is some leakage plus Q2. This leakage has given 0.1 Q2. So total it will become 1.1 Q2 AP into Vp. So he has given Q2 is equal to 300 centimeter cube per minute. That is 300 into 1000 mm cube per minute. Okay. So now area of plunger is also given AP is equal to 500 mm square. So you can calculate Vp is equal to 1.1, Q2 is 300 into 1000 divided by area of plunger is 500. You will get it is 660 mm per minute. Answer is 660 mm per minute for the question number 11. And coming to question number 12. So he has given in this problem. So I think the question given was the wrong. So 12 inch outside diameter and 10 inch inside diameter. So where is the outside diameter? Where is the inside diameter? So I haven't solved this question. Okay, I left that. And coming to next question. A 420 feet waterfall shown in the figure involves a steady flow from one large water body to another. Determine the temperature change associated with this flow. So first of all, this 420 feet, I am converting 420 feet into meters. 128.016 meters. Clear? So now I will assume when the water is at certain height, it will possess potential energy. Okay, so I am treating all potential energy gets converted into temperature energy. So the potential energy is m dot GH and temperature energy is m dot C delta T. So C for water, there is a constant for water is equal to 4.187 kilojoule per kg. Okay, so m dot will go cancelled. So from this equation, 9.81 into H is height, that is 128.016 and C is equal to 4.187 and the change in temperature is delta T. So we got delta T as 299.937 Kelvin. So and there is one formula, C by 100 is equal to F minus 32 by 180 is equal to K minus 273 divided by 100. This is a conversion. So he asked in Rankine scale. Rankine scale is nothing but we need to substitute the value in Fahrenheit. Okay. So we need to calculate F. It is 80.4666 Fahrenheit. Okay. So the answer is 80.466. Clear? So now last question. When a body moves through a still water at a constant velocity 4.5. So I am taking the body A. It is moving 4.5 meter per second, and the velocity of water at a point M, which is how much distance? 0.8 meters ahead. The nose of the body is moving this with 3 meter per second. Okay, so what is the difference of pressure between the nose and the 0.8 meters ahead? Express it is in Newton per meter square. We need to mention the pressure in Newton per meter square. I'll apply Bernoulli's equation at point A and B. Okay, so PA by gamma plus VA square by 2G plus ZA is equal to PB by gamma plus VB square by 2G plus ZB. So both ZA and ZB are different, same. PA minus PB divided by gamma is equal to VA square minus VB square by 2G. So if I send this gamma, it will be gamma here. So I am neglecting here. So gamma is equal to rho G. So G will go cancelled. VA square is 4.5 square minus 3 square into 2 into 9 point. So rho is 1000, not 9.81. So this difference PA minus PB is equal to 5625 Newton per meter square. Okay, so the answer is 5625 Newton per meter square. Clear? So these are all the simple problems, and there is a lot many more problems here related to theory. Okay, thank you.